Hello everyone, welcome back to Math Academy. Today in this video I am going to explain another important chapter in mathematics, which is quadratic factorization in algebra. Before I begin, please note, if required, review the previous video posted on algebraic expressions to clear the foundational knowledge in this chapter. For example, variables, coefficients, constants in algebraic expression, degree and types, like terms and unlike terms, evaluating and simplifying. In this video, I will cover algebraic expression recap, quadratic expression introduction, quadratic factorization introduction, and various types of quadratic factorizations. Algebraic expression recap. An algebraic expression in mathematics is an expression containing one or more algebraic terms involving variables, constants, and operating symbols like plus and minus signs, etc. Example: 2x, 2x plus 3y, x square plus 2x plus 3. All these are algebraic expressions. So here we can see 3x plus 2, which is an algebraic expression. There are two terms here. One is 3x and there is another term is 2. So this 3 here is called coefficient, x is variable, plus sign is the operator, and 2 is constant. So one more time, in this algebraic expression 3x plus 2, there are two terms. One is 3x, another is 2. 3 is called coefficient, x is called variable, plus sign is the operator here, and 2 is constant. And there are two terms in this algebraic expression. Quadratic expression introduction. A quadratic expression in x is an expression of the form ax square plus bx plus c, where x is the variable and a, b and c are constants with a not equal to 0. So ax square plus bx plus c, where a, b and c are constants, a not equal to 0. If a equal to 0, then this first term vanishes. So that's why it won't be a quadratic expression anymore. That's why a not equal to 0 is a condition to be a quadratic expression. Here x is variable, a, b and c are constants. Also first term, which is x square term, is ax square. Second term, which is x term, is bx, and third term or constant term is c. Example: x square plus 2x plus 3, x square plus 5x, all these are quadratic expressions. As we have already mentioned in the previous video, that x square plus 2x, all these are quadratic expression because the highest power in these expressions is 2, always 2. So here x square plus 2x plus 3, the highest power of the variable is 2. In this one also x square only, the highest power is 2, although there is no x term or constant term. Again in this third one, again highest power of x is 2, that's why it is a quadratic expression. Quadratic factorization introduction. Factorization is the process of writing a number or an algebraic expression as a product of factors. Example: x square plus 5x plus 6. Let's see how we can factorize this. So x square plus 5x plus c can be written as x plus 2 times x plus 3. So there are two factors here. So this is the quadratic expression, x square plus 5x plus 6, and this is the factorization form, or these are two factors. X plus 2 is one factor, x plus 3 is another factor. So from this quadratic expression to this factorized form, we call this procedure as factorization, and this is called expansion. From this factored position to this position, this is called expansion. So this is factorization and this is expansion. So x plus 2 and x plus 3 are the two factors of the algebraic expression x square plus 5x plus 6. So this is the algebraic expression or quadratic expression, and these are the two factors x plus 2 and x plus 3. So factorization is the opposite or reverse process of algebraic expressions. Types of quadratic factorization. Various types of quadratic factorizations are factorization by removal of common factors, difference of two squares factorization, perfect square factorization, grouping in pairs factorization, quadratic trinomial factorization, factorization by splitting the middle term. Let's dig into it one by one. Factorization by removal of common factors. This factorizing method is based upon the removal of highest common factor or HCF of all the terms. Highest common factor or HCF or greatest common factor or GCF of two or more algebraic expressions is the product of all their common prime factors. For example, HCF of 4x and 2x times x square plus 1 is 2x. So 4x is one expression and 2x times x square plus 1 is another, and the HCF or highest common factor is 2x, because 2x is the only common prime factors in both. That's why 2x is the HCF. In order to understand the method of factorization by removal of common factors, the most relevant concept is to understand the distributive property. What is distributive property? A times b plus c equal to ab plus bc. So we just multiply this a, multiply b by a and multiply c by a. We just get this expansion, and this is called distributive property. Now examples: factorization by removal of common factors. 4x plus 12y. Here we can see only common factor is 4. We take 4 as a common factor here, and the remaining x plus 3y. X is here from 4. If we take 4 as a common factor out, then we have x as a leftover and 3y here. Similarly, 9ab minus 12bc, here 3b is the common factor and 3a minus 4c is another factor. Minus a square plus b minus b square a, here minus ab is the common factor. We take it out and we have a here left over and b here. So these are very straightforward. We are just trying to take the we remove the common factors from all the terms. So there are more examples here. Let me explain this. So here 2a minus 2 plus b 2 minus a. Little bit tricky here. What we are doing, just to find the similarity, a minus 2, we take a minus common here, minus after taking the minus as a common factor here, we have a minus 2. So 2 minus a is changed to a minus 2, so that we have a minus 2 and a minus 2 as a common factor here, and the leftover is 2 here and minus b here. But the tricky part is here, if we don't take this minus common from here, this minus, these two don't match. So once we take this minus common here, we have a minus 2 and a minus 2 as a common factor here. Another example, x minus 5 whole square minus 2x plus 10. What we are doing here, we are taking a minus 2 common factor here from these two terms. So once we take minus 2 common from these two terms, we have x left over here and minus 5 here, so that we can take another common factor from these and these, which is x minus 5. So from this line we are writing down x minus 5 as a common factor here. So the leftover here is another one more x minus 5 here, because there was a square here. So once we take one x minus 5 here, we have another x minus 5 in this, so that is here, and minus 2 here. Then on simplification we get x minus 7 here. There is a worksheet here, you can try this one, just by factorization by removal of common factors. If there is any question, feel free to reach out to me through comment section. Difference of two squares factorization. The difference of two squares can be factored by applying the following formula: a square minus b square equal to a plus b times a minus b. So this is the most common formula we always use to for factorization of difference of two squares type. This is another type of factorization, but a and b can be any algebraic expression here. The expansion of a plus b times a minus b is a square minus b square, whereas the factorization of a square minus b square is a plus b times a minus b. So from this one, when we write down this is the factorization, and from this one to this one, this is called expansion. This formula is not applicable to a sum of two squares. So remember, this formula is only applicable for difference of two squares. A square minus b square is equal to a plus b times a minus b, but there is no such formula for a square plus b square. That's the note here. Examples: a square minus 25 is a square minus 5 square, so a plus 5 times a minus 5. Similarly, 4x square minus 9y square is 2x square. We can write down 4x square as 2x whole square, minus 9y square means 3y whole square. Now we can consider a square minus b square, which is a plus b times a minus b, 2x plus 3y times 2x minus 3y. Examples: difference of two squares. We have some more example here. So 2x square minus 8, basically we have to take a 2 as a common factor out, so that this becomes x square minus 4 after taking 2 as a common factor. So x square minus 4 means we can write down x square minus 2 square, which is x plus 2 times x minus 2. 8x square minus 18, we take another 2 as a common factor out, so we have remaining 4x square here and minus 9 here. So 4x square means 2x whole square and 9 means 3 square. So again we apply the formula a square minus b square. So a plus b times a minus b. Here it is 2x plus 3 times 2x minus 3. Minus 9x square plus 16, we take a minus 1 common here, so this becomes 9x square minus 16 after taking minus as a common factor out. So 9x square becomes 3x whole square minus 4 square, so 3x plus 4 times 3x minus 4. Alternate solution is if we just rearrange this, instead of taking a minus as a common factor out, we can just rearrange this one. So minus 9x square plus 16, we can write down 16 minus 9x square. Then 16 means 4 square and 9x square means 3x whole square. So now we can apply a square minus b square equal to a plus b times a minus b formula. So 4 square minus 3x whole square equal to 4 plus 3x times 4 minus 3x. So this solution and this solution basically they are same. Here there is a minus 1 common factor out here, and but this minus is absorbed here in this solution. So instead of 3x minus 4, it is 4 minus 3x, because the minus is not here, it is absorbed here inside. Another example here: 2x times x square minus 4 minus 4 times x square minus 4. So just by observation we can see x square minus 4 is common, so we take this common factor out initially, then we have 2x here and minus 4 here. Then x square minus 4 means x square minus 2 square, and from these two we can take another 2 common factor out. So after that this becomes a square minus b square means a plus b times a minus b. So x square minus 2 square means x plus 2 times x minus 2, and this 2 common factor is out here. We have another x minus 2 here. This is another example, very straightforward, just x plus 3 whole square minus x minus 2 whole square. We consider this as a, so a square, minus this as b square. So a plus b times a minus b, then simplification. These parts on simplification it gives us x 2x plus 1, and this part on simplification gives us 5. So this 5 is comes to the left side, so 5 times 2x plus 1. Now perfect square factorization. The expansion of a plus b whole square is a square plus 2ab plus b square. The factorization of a square plus 2ab plus b square is a plus b whole square. Similarly, the expansion of a minus b whole square is a square minus 2ab plus b square, and the factorization of a square minus 2ab plus b square is a minus b whole square. So a square plus 2ab plus b square is a plus b whole square, and a square minus 2ab plus b square equal to a minus b whole square. Remember, a plus b whole square and a minus b whole square, these are called perfect squares. Example, x square plus 4x plus 4, we just rearrange this x square 4x, we can write down 4x as 2 times x times 2, and 4 is 2 square. So this is in the form of a square plus 2ab plus b square, which is a plus b whole square. In this case it is x square plus 2 times x times 2 plus 2 square. That's why we can write down x plus 2 whole square. So this is perfect square factorization. Now 4x square plus 12xy plus 9y square, we reorganize again. 2x whole square plus 2 times 2x times 3y plus 3y whole square, which is 2x plus 3y whole square. X square minus 10x plus 25, same procedure, we just rearrange this. X square minus 2 times x times 5 plus 5 square, which becomes x minus 5 whole square. Minus 16x square minus 48x minus 36, we take minus 4 as a common factor out, then we have remaining 4x square plus 12x plus 9. Then we can, just by rearranging it, we can write down this perfect square form. So this is 2x whole square plus 2 times 2x times 3 plus 3 square, which is 2x plus 3 whole square. Same here, minus 3x square plus 30x minus 75. So we take minus 3 as a common factor. Here x square minus 10x plus 25. On rearranging it, we get minus 3 times x minus 5 whole square. So all these are perfect square factorization. Now we move to grouping in pairs factorization. In some cases, although there is no common factor to all terms of an expression, grouping in pairs and taking the common factor out serves the purpose. So we just concentrate on grouping the terms. Here is an example: 8ax plus 4bx plus 3b plus 6a. So in this example, we just out of these 4 terms, we group them: 8ax plus 4bx in one group and 3b plus 6a another group, although we write down in the other sequence 6a first, then 3b later. So after that, we take 4x common factor from these 2 terms, and we have 2a plus b. Then 3 from these 2 terms, 3 as the common factor, we have 2a plus b here. Now 2a plus b, we take it a common factor out here, and we have left over 4x here and 3 here. That's how we factorize by grouping in pairs. These are the steps. Step 1, observation if no factors common to all terms. At first we see there is no common factor for each and every term. If there is one, we should take it out first. If not, then we proceed to the next step. What is that? Grouping terms with common factors together. So first we observe no common factor, then second step we are grouping these terms like this. This grouping is the step 2. step 3 taking the common factor out. So in step 3 we are taking common factor here this one and common factor here this one. Then last step again we are taking the common factor. So these are the 4 steps. Alternate solution to this problem, we can group in a different way. Here we were grouping 8x and 4bx together and 3b and 6a together, but here we are grouping in a different way, 8x and 6a together, whereas 4bx plus 3b separately. But after taking the common factors we get the same result, although in a different sequence, but it is same result. So it doesn't matter about how we are grouping them. Grouping in pairs examples, 2ax minus 5a minus 2bx plus 5b. Here we are grouping 2ax and minus 5a in one group and 2bx and 5b in another group. Because there is a minus sign, we have to change the sign of this so that on removal of this bracket we get plus 5b back again. So we have to be mindful here. After that a is common factor in these two terms and minus b is the common factor here, and then again 2x minus 5 is another common factor here. Another example, px minus qy minus py plus qx. So px and qx we group them together and minus py and minus qy here. Then we take the common factor out here. Here x is the common factor, here minus y is the common factor. After that p plus q and p plus q is the common factor here. So x is remaining here and y is here. This is another example, 5xy minus 3y plus 10x minus 6. 5xy minus 3y is in a group and 10x minus 6. Then y is the common factor here, 2 is the common factor here, and 5x minus 3 is common factor here. So ultimately we reach at this point where there are two factors in two brackets, they are multiplied like this. This is the most important part. 2x square minus 15 plus 3x minus 10. So 2x square minus 10x here in a group and 3x minus 15 in another group. So 2x is common factor from these two and 3 is common factor from these two, and x minus 5 is the common factor here. Quadratic trinomial factorization. A quadratic trinomial is a standard quadratic expression with three terms of the form ax square plus bx plus c, where x is the variable and a, b and c are constants with a not equal to 0. So ax square plus bx plus c, x variable, a, b, c constants and a not equal to 0. Example, x square plus 5x plus c or x square minus x minus 6 are the quadratic trinomials. So quadratic means highest power of the variable is 2. That's why it is quadratic. And trinomials means there are three terms in these quadratic expressions. There are three terms, 1, 2, 3. 1, 2, 3. So ax square is the first term, bx is the second term, c is the third term. That's why three terms, that's why trinomials. And highest power of the variable x is 2, that's why it is quadratic. Let us consider the expansion of the product x plus 2 times x plus 3. So x plus 2 times x plus 3, we multiply by x to this, then x to this. So x times x gives us x square, x times 3 gives us 3x, then 2 times x gives 2x, and 2 times 3 gives 2 times 3. So just this is the way how we multiply these products. So x plus 2 times x plus 3, this x times this x, then this x times this 3, then this 2 times this x, and then 2 times 3. That's how we get 4 terms. So x square, 3x plus 2x is inside bracket like this, and 2 times 3. So x square plus 3 plus 2 means 5x plus 6. So on expansion of this product, we get x square plus 5x plus 6. Coefficient of x here, this coefficient of x here is the sum of 2 and 3. So these 2 and 3, their sum is the coefficient here, and constant term 6 here is the product of these 2 and 3. So these 2 and these 3, the sum of those two numbers is the coefficient of x here, and these 2 and these 3, the product of these two is 6 here. Quadratic trinomial factorization, general form is x plus a times x plus b. So on multiplication we get x times x is x square, x times b is bx, a times x is ax, and a times b is a times b. So x square, this bx plus ax we can write down in this form, a plus b inside bracket times x plus a times b means ab. As we have mentioned earlier, coefficient of x is the sum of this a and b. Sum of this a and b is the coefficient of x here, and constant term is the product of a and b. This a and b, product of a and b, this is the constant term because there is no variable here. X is absent here, that's why it is constant. So in order to factorize x square plus 5x plus 6, we need to look for two numbers with a product of 6 and a sum of 5, because this is the coefficient of x, which is the sum of 5, and the product of 6 means 1 times, there is coefficient 1 here, 1 times 6 is 6, that's why we need to look for two numbers with a product of 6 and a sum of 5, and these two numbers are 2 and 3. 2 and 3 are the two numbers, product of which is 6 and sum of which is 5. So x square plus 5x plus c, we can write down x square plus 2x plus 3x plus 6 means x plus 2 times x plus 3. This method is also known as sum and product method. Example. So x square plus 7x plus 12, we can see sum a plus b equal to 7, product ab equal to 12, sum a plus b equal to 7, product ab equal to 12. Therefore a and b are 3 and 4. X square plus 7x plus 12 equal to x plus 3 times x plus 4. X square minus x minus 12, in this case sum a plus b equal to minus 1, product ab equal to minus 12. Therefore a and b are minus 4 and 3. These are the two numbers only by which we can get a plus b as minus 1 and ab equal to minus 12. That's why the factorization is this: x square minus x minus 12 equal to x minus 4 times x plus 3. 3x square plus 9x minus 12. In this case we can take a 3 as a common factor out. So x square plus 3x minus 4. Now we can see, removing 3 as a common factor, we have sum 3, this sum 3 and product minus 4. That's why numbers are 4 and minus 1. So x plus 4 times x minus 1. This is the factorized form. So there is some more example. X square minus 16x plus 64. We can see sum is minus 16, sum is minus 16 and product is 64. So numbers are minus 8 and minus 8. That's why the factors are like this: x minus 8 times x minus 8. Alternate solution of this case, we can rearrange this as a perfect square. X square minus 16x plus 64 means x square minus 2 times x times 8 plus 8 square, which is x minus 8 whole square, and we can write down x minus 8 times x minus 8. Minus 2x square minus 2x plus 12, we can take minus 2 as a common factor, so it becomes x square plus x minus 6. So the sum is 1 and product is minus 6. Therefore the numbers are 3 and minus 2. Therefore minus 2 is here and x plus 3 times x minus 2. This is another case, x minus 2 whole square minus 4 times x minus 2 minus 5. We can consider this x minus 2 as a. So this expression becomes a square minus 4a minus 5. We consider x minus 2 as a. That's why we can rewrite this expression as in this form. And then we can see the sum is minus 4, product is minus 5. That's why numbers are minus 5 and 1. So we can write down a minus 5 times a plus 1. Then we have to substitute the value of a, which is x minus 2. So instead of a, we write down x minus 2 minus 5 as it is. And here x minus 2 again plus 1. Then on simplification, we get this. Now factorization by splitting the middle term or x term. In the previous sections, we were dealing with factorizations of quadratic expression in x of the form ax square plus bx plus c, where a, b and c are constants with a not equal to 0. Now in each case, a was one of the following. For example, a equal to 1. For example, x square plus 5x plus 6. Here we can see a equal to 1. Either this case or a is a common factor like this, 2x square plus 10x plus 12. We can take 2 as a common factor out. So x square plus 5x plus 6. Or a is part of a perfect square like x square minus 10x plus 25, which can be written as x minus 5 whole square. Or a is part of a difference of two squares, 2x square minus 50. We can take 2 as a common factor out, and then x square minus 25, which is x square minus 5 square. So in this case, so far we have seen any one of these cases, a equal to 1, or a is a common factor, or a is part of a perfect square, or a is part of a difference of two squares. But what happens if a not equal to 1, or in any other case? Factorization by splitting the middle term or the x term is the way. Let's see. Let's have a look on the expansion of the factors 2x plus 3 times 3x plus 4. So we multiply 2x times 3x 6x square, then 2x by 4 8x, then 3 by 3x 9x, 3 multiplied by 4 12. So 6x square plus 8 plus 9 times x plus 12, which is 6x square plus 17x plus 12. Now let's reverse the process to factorize the expression. So 6x square plus 17x plus 12, we write down 6x square plus 8x plus 9x plus 12. Then we group them, 6x square plus 8x plus 9x plus 12. Then we take the common factor from these two, which is 2x. 3x plus 4 is the remaining, and 3 here. So we have this. Now common factor again, 3x plus 4. So we have remaining 2x plus 3. Now here we are splitting the middle term 17x as 8x plus 9x. Next we are grouping in pairs. Then we are factorizing each pair. Then completing the factorization. But the question is how to split the middle term. On what basis we are splitting 17x as 8x plus 9x? Let's see. Let's investigate and explore how to split the middle term accurately. So 6x square plus 17x plus 12. We have written down 6x square plus 8x plus 9x plus 12. Now, how do we know 17x should be written as plus 8x plus 9x? So, 6x square plus 8x plus 9x plus 12. Here we can see 6 times 12 equal to 72. Say this coefficient of x square is 6 and the constant 12. So 6 times 12 equal to 72. And also we can see 8 times 9 equal to 72 as well. So 6 times 12 equal to 72. 8 times 9 equal to 72 as well. But there is another important part, which is 8 plus 9 equal to 17. So this 8 plus 9 has to be same with the 17. So the product of this term and this term is 72. 6 times 12 equal to 72, and 8 times 9 equal to 72 as well, but 8 plus 9 equal to 17. So these are the three conditions to rewrite this 17x as 8x plus 9x. That's how we determine. So this 72, this is also 72 same, but the sum of these two is equal to this 17. So for 6x square plus 17x plus 12, we need two numbers whose sum is 17 and product is 6 times 12 equal to 72. These numbers are 8 and 9. So quadratic standard form is ax square plus bx plus c. Steps to follow to factorize by splitting the middle term. These are the steps. Step 1, find the product of AC. So this A and C. Step 1 is find the product of AC. Step 2 is find the factors of AC which add to B. So after we get the product of AC, this product AC, we have to find the factors of AC. Those factors will add to B. That means the factors, whatever factors we determine for AC, on addition they will give us B. So the factors of AC will give us on addition we will find B. If the factors of AC are m and n, replace bx by mx plus 9nx. Finally, group and complete the factorization. Example 4x square plus 8x plus 3. So we see AC equal to 4 times 3. So A and C, like this, A and C, we find the product as 12 and B equal to 8. Now we need two numbers with product 12 and sum 8. So numbers are 6 and 2. So here is an example 4x square plus 8x plus 3. We see AC equal to 4 times 3 equal to 12 and B equal to 8. Now two numbers are needed with product 12 and sum 8. So numbers are 6 and 2. So solution, in the first part we will do this 4x square plus 8x plus 3. So 4x square plus 6x plus 2x plus 3. Then we just take we group them, 4x square plus 6x in one group and 2x plus 3 another group. Then common factor 2x from these two and 1 from these two, so that we get 2x plus 3 common factor again. So this is example 2, 2x square plus 3x minus 5. Here we can see AC. So A is 2, C equal to minus 5. So AC equal to minus 10. And B we can see 3. Now two numbers are needed with product minus 10 and sum 3. So the numbers are 5 and minus 2. So that we on multiplication we get the product as minus 10. And if we add them, we get the sum as 3. Therefore, the first part of the solution is 2x square plus 3x minus 5. We write down in this form 2x square plus 5x minus 2x, because the numbers are 5 and minus 2. So 5x minus 2x minus 5. Then grouping. So we write down this as as a group and this part as another group. Then common factor x here and common factor minus only minus here means minus 1. So final common factor is 2x plus 5. This is another example 3x square minus x minus 10. We can see AC equal to minus 30 and B equal to minus 1. So two numbers are needed with product minus 30 and sum minus 1. So numbers are minus 6 and 5. Similarly, minus 5x square minus 7x plus 6. Here we can see the product AC equal to minus 30 and B equal to minus 7. So two numbers are needed with product minus 30 and sum minus 7. numbers are minus 10 and 3, so we write down this minus 7x as minus 10x plus 3x, then grouping, then common factor, then common factor again. On just we write down this part as instead of minus 5x plus 3 we write down 3 minus 5x. It looks better. So that's it. Thank you for watching this video, and like, share and comment, and